PCN tours the Keystone State, taking you inside Pennsylvania's factories, museums, and historical sites.
Hello, my name is Denise Yanni. I'm the Sales and Marketing Manager, and we are S&L Plastics. We are where plastics takes shape. What I'm standing in front of is an ice storage bin. This was supplied to us courtesy of our customer, the Follett Corporation in Easton, Pennsylvania. This particular item has few of our components that make up the product. If you look inside the bin, on the bottom of the assembly, you'll see a drain. This particular part is done through our process called injection molding. If you look at the corners of the bin, those are supplied by us as a profile extrusion. And if you look at what makes up the inside of the bin, the light blue part, that poly is provided by us in a sheet extruded form. Our customer, Follett, takes our components and manufactures these bins in their location. Between our injection molding, our profile extrusion, and our sheet extrusion, we really are a one-stop plastic shop. Our business was started in 1946 and originally started in the blown film industry. We've evolved and changed and actually moved locations quite a few times, which brought us to where we are today. Currently, the business is privately owned by a company named the Westfield Capital Company. What you're seeing here is our warehouse. Another thing that makes us unique to our customers is that we stock over 200 different resins and colorants. We are truly what you would call a custom house. What you'll see throughout this aisle is resins that are both commodity in nature as well as engineering grade, such as nylons by DuPont. What we want to show you today is taking our products from pellet to process. Our processes here include injection molding, profile extrusion, and sheet extrusion. We also do value-added items such as fabricating, assembly, annealing, miter cutting, etc., depending on the customer's particular need. Now we're out on our production floor, and the first process we're going to look at is our injection molding process. Barb Miller here is the operator working on the job, and what she's doing is removing the parts from a threaded insert. This particular job is run on a family mold and creates all three parts that are used in that drain assembly that I showed you earlier. It's a male, a female, and a nut for the entire assembly. This mold was built in excess of 20 years ago. When we knew we were doing this shoot, we went back through the records to try to get an idea of how long ago this particular mold was built and designed. Neither us nor our customer could actually correlate when it was started, but it is in excess of 20 years. The material chosen for the job was a rigid PVC. This material was chosen because it's very common in the plumbing industry and it holds up well against normal cleaning agents such as bleach. When a mold is designed, as in this case with PVC, the particular plastic resin is taken into account when you're figuring out the shrink factors for the tool, as well as the steel design. This mold has stainless steel foreign cavity inserts due to the corrosiveness of rigid PVC. PVC is a material that is known for its gassing. What that means is that the chlorine gases are released during the processing of the material. What this could do is corrode or pit your mold. Due to this fact, we ended up using stainless steel for the design. If you look at the machine here, this is a 132-ton Nisi press. If you look a little closer, there's a hopper feeder on the top. Many of our resins have to be dried prior to processing. Plastic is normally hygroscopic in nature, which means it will absorb moisture from the air. This resin was dried prior to being put in the hopper in an oven with a tray dryer. The material is fed through the hopper into the barrel of the injection molding machine. Inside the barrel is a threaded screw. The pressure of the screw grinding against the barrel will create the stress that's needed to push the plastic material that's in a molten state through the mold. The main cost features that make up the component cost of the finished part is actually the material, which is the PVC, and the processing. Processing is really governed by your cycle. Your cycle is basically how many parts you'll be getting in how many seconds per hour. In this particular case, it's made up of the plastic coming through the barrel into the mold, the cooling of the parts in the mold, and the time it takes for the operator to actually unscrew the parts, put new inserts in the mold, and shut the door. The original design of this mold was done with these inserts to keep the tool cost down so that the mold didn't have to be created with an unthreading feature built in. When you look at your material choices, such as the PVC, as was chosen in this case, the material governs the final weight of your part. That weight is really based on the specific gravity of the resin. For example, in this particular drain assembly, if you made the same part to the exact same cubic inches in a different resin, it could weigh more or less, depending on the specific gravity of the other resin chosen. Now we're in our sheet extrusion department. Right now we're extruding linear low-density polyethylene. This is the resin that's used on the inside of the ice bin I showed you earlier. This particular resin was chosen because of the good impact in cold weather temperature that it exhibits. Every job we do is independent based on the customer's specific properties that they're looking for. For this ice bin, not only did they need the good cold temperature impact, they also needed FDA and sanitation specifications that the end product had to meet. This resin complies with all of them. This particular resin is vacuum fed up into the loading system. Many of our other resins are actually fed direct from silos. The majority of the resin run through our sheet department is all polyolefin in nature. That means it's either a polyethylene, a polypropylene, or a modified polyethylene elastomer, or a variation thereof. The current line we'll be looking at for the ice chest liner is a 3-inch Sterling extruder. What that signifies is that the diameter of the inside screw for the machine is actually 3 inches. If you follow me around, you'll see where we're also vacuum feeding regrind and colorant. That is used to produce the sheet. All of these materials are vacuum fed up into the hopper, which is located on the top of the machine. Everything is meter fed to make sure that it is used at the correct letdown ratio. All customers have specific requirements as to the min or the max amount of regrind that's allowed to be used in a product, as does this account. Right here are our heat settings. What these control is both the barrel and the die temperatures. The plastic material is actually extruded through the barrel into the die. The die is set at different heat zones. We also have what we call a lip opening, which is the amount of thickness that the particular die is set at to get the end thickness of the product. This particular product will be 3/16 inch thick. From the die, the plastic is extruded into the nip rolls. What these rolls are is a series of 3 rolls that create the texture. Your top roll has what's called a hair cell finish on it. What this does is create a grain on the finish of our customer's sheet. The second roll has what's called a sandblast finish. This is more or less a matte finish. And the bottom roll is simply a polish roll. These 3 rolls also have their own temperature settings. You could say we're somewhat cooling it, but actually usually they're set about 100 degrees below where the molten plastic is coming in at. So it's bringing the temperature down at a controlled rate, but it's not exactly what I would call cool. All of our sheet is run at a controlled speed. This particular product is run relatively slow as far as feet per minute that actually comes out of the extruder. This job has extremely tight tolerances as far as the length and width of the sheet. It's run at this speed to assure a quality product for the end use. Process called corona treating of the surface. What this does is it oxidizes the surface of the poly to assure that the poly will allow itself to be glued or printed. Our customer actually uses the surface that's the hair cell side closest to the interior of the bin that they bond to their stainless steel. Due to this fact, they have us treat that surface so it takes to the foam that they use for their insulating that's bonded on the inside of the bin. What you'll see above it is a hood. What this hood is basically just to cool off any excess fumes that may be let off from the process. What you're looking at here is our knife settings. What the knife settings do is they trim off the excess sheet that's produced from the die so that the width of the sheet is to our customer's specification. We run on a 64-inch wide die normally, which will give us a maximum yield of 60 inches at top end of good sheet. For thinner gauges, we actually limit it to 56 inches of the yield of sheet due to what you're seeing on the ends of the sheet where it actually starts to thin itself out. This particular job has fans blowing on it as well to try to cool some of the heat from the sheeting. As the poly comes through the shear blade, there's a counter on the machine, which you'll see here. What the counter does is it works with the nip or the pull roll to give the chopper a signal as to when it's to come down to assure a good length on the poly sheeting. This particular size is set to chop at 100 inches. So you'll see the chopper come down, which is the guillotine blade over there, when it hits that mark. What you see coming off the edges of the product will actually be put back in a grinder and ground back up to regrind form to be used back in at the metered ratio of the customer for the product. What Chris is doing is he's grinding up the edge trim that'll go back in the Gaylord as you saw in the rear. One of the nice things about plastics is that the majority of them are recyclable, as you see with your recycle symbols on your household products. It makes it an environmentally friendly material. What they're doing here is they're taking measurements for our customer for quality records. All of the quality recording we do is based on the end customer's specific requirement. In this case, we're paying attention to what the length of the product is. The length of our sheeting correlates with the wraparound of the inside of the bin you saw. The width of our sheeting actually makes the height of the bin you saw in the rear. What Chris is doing now is taking some measurements off the poly. We record both the temperature ratings as well as the actual physical measurements. We also spot check for the level of corona treating to make sure that what our customer needs for the surface level is adequate. Now let's move on to our profile extrusion department. What you're going to see here is a 2.5-inch extruder extruding that corner piece that created the inside joiner for that bin. You can look in here. What you're seeing are ABS pellets. ABS is acrylonitrile butadiene styrene. It's a Tour polymer as far as plastics go. What that means is it's created of 3 monomers. This particular resin was chosen for its strength properties. It also meets the sanitation criteria that our customer required for their use. It's a common material used in automotive applications and housewares. What we have on the machine right there is a hopper loader, and to the side, off to the right, you'll see a dryer. What that dryer is doing is blowing air in and pulling air out to pull the moisture off the resin as the pellets are being fed down that hopper into the throat of the extruder. This particular ABS resin is run at temperatures of around 350 degrees. The temperatures are controlled very tightly throughout the zones of the extruder barrel, which is back here. The extruder is broken into 3 zones, and the temperature controls to my right are what controls that. We also monitor the temperature of the die and the adapter equipment. Right here is the die. What that is the piece of equipment that creates the shape of the part. All of our dies are designed and built in-house on our 4-wire axis wire EDM machine. Every die is unique to the specific material and end specifications of our customers. Dies are built to a size that's actually swelled in comparison to what the end part is supposed to measure. And this is done at a systematic ratio that our engineers use based on the material. On the die, we use heater bands to help bring the temperature up on that piece of metal. And we also use thermocouples, which help measure and monitor the temperature of the die. From the die, it's actually going into a sizing plate in the fixtures. For this particular job, this set of plates and fixtures involves a vacuum system. This die design has vacuum ports coming up through the plate. In between this piece here are little slots. and they're vacuum port slots that help pull the part to the correct outside dimensions. This part is run through water to pull the heat from the material and helping pull the part. And then it's taken into our puller. This job is set with a stop. As you're seeing, the saw blade comes up from the bottom to cut the part to the proper length. All cutters are chosen based on the type of job and the type of material and the wall thickness of the finished part. With a lot of smaller jobs or thinner wall thicknesses, we may use fly knife cutters, which would give us a quicker cut. In this case, this particular part is a relatively heavy wall, so we chose to use a saw blade. This is the final component piece of that ice fan that I showed you at the beginning of the show. Now as we've walked through the plant, I'm sure you've overseen some of the other areas where we're producing products. If you want to come along and continue the tour, we'll show you some of the other things we do. What we're running on this product line is a nylon 11 tubing. This is part of our in-house stock product line. This particular job is a 1/2 inch oak OD, and it's a nylon 11 low moisture material. It's geared for higher flex applications. This is part of our NylaFlow product line. This product line consists of heavy wall, which is a nylon 6/6 grade, thin wall, which is also a nylon 6/6 grade, and the nylon LM product line, which is the low moisture, high flexibility material, which is a nylon 11. The material is coming out of the die and going into a vacuum chamber. The vacuum chamber is filled with water, and it's cooling the part and pulling it to size. The tubing then continues down through the water trough where it enters a haul-off or a puller. This is just helping to move the tooling along and pull off a little bit of the water that got on the tubing from the water bath. After it comes to the puller, it enters a Zumbach, which is a gauging system to help monitor the outside dimensions of this tube. Since it's our stock product line, every tube we produce is published to a specified tolerance listing. From there, it proceeds through a printer. All the tubing we produce in-house is marked with a date coding system. What this does is it labels the tubing as to the type of material and the product line and the size that it represents, but it also gives it a date code for traceability or lock control. If there would be a problem with our tubing, if our customers gives us a piece of this with the literature as stamped on it, we can trace it back to the given production run that it came from. This tube is currently being wound on a master spool. These master spools are taken off to another area where they can be wound down and put into smaller coils. Our product line varies. We have some product that's sold in stock in 100-foot coils, some that's sold in stock in 500-foot coils. All of it is polybagged and packaged under our NylaFlow trademark. Since you're here on tour, there's one more thing I'd like to show you. It's a product line we have called Measurex. Once you see it, I'm sure it'll be familiar to you. It's a component that's found in a lot of dry beverages and cocos. Come on, I'll show you. This particular product line It's about 95% polypropylene. That's because of the good chemical resistance that this material inherently has. What they're doing here is screening the parts as they come off the machine. Any product that's an FDA measure is run at an area where we have an operator with a lighted table. It's a special fluorescent lighting that's put at the machine so that the operators can pick up any signs that are symptomatic of a problem with the machine, such as grease. You're also seeing the gloves and the hairnets, which are required because of the FDA applications that most of these scoops are used in. They're not limited to that, though. Many of our customers also use them for pet food or agricultural uses, such as fertilizers, bird seeds, it could be pool chemicals, anything. They have multi-uses. When you open a package of your dry beverage, if there's a little logo on the bottom that says Measure X, that's our product. We're in many of the major brands, such as your Gatorade, your Procter & Gamble's, some of your cleaning agents that are out there that are granular in nature, and some of your bulk Swiss Miss Cocos. Many of our customers also add color into the scoops. They can add a custom color that could match the scoop to the lid of their product. They can add a color that could coordinate the scoop to the label of their product. In this particular case, this is a natural scoop, which means it's the resin in its virgin state with nothing added to it. What she's doing now is taking the runners that come off with the product and putting them back into the scrap grinder. Everything that's being produced that's going into that grinder is completely recyclable. The mold you're watching is a 32 cavity mold. What that means is there's 32 pieces coming out per shot. These molds vary in the type of cycle they run. Some may be as low as 13, some may run as much as 20-some seconds within the scoop product line. In our custom product line with some of the heavy wall products, we have some items that may be well over a minute. This is one of the smaller scoops we produce. Our scoops go from a 0.15 cc size up to a 16-ounce size. Our larger scoops, such as our 8-ounce and our 16-ounce, are used in pet food, such as promotional items such as the IAMs that you might see in the pet stores. It's usually silkscreen with their logo. We also have some scoops that are sold to granular chlorine companies who sell it or give it away as a promotional item to people when they're buying their granular chlorine to walk over to their pool and throw it in with a scoop. I'll show you one of the larger sizes down here. What you're seeing here is our 8-ounce rectangular scoop. This is a small pitcher style scoop that's designed to be able to pour the product from the scoop. This one is also being done in a natural polypropylene resin. Our scoops are also calibrated to a specific cc range. Our product is closely monitored, and we publish a specified tolerance for the cc level that the scoop is supposed to be able to measure. We have over 40 different stock sizes available, and we try to ship within 24-hour notice. All the products are UPS-able. And they're also available for order off of our website, which is www.slpinc.cc. What you're looking at here is our inventory. The majority of what you'll see down this aisle is our stock measuring scoops. What's sitting here is staged for shipment that's going out to customers today. If you look down the aisle, these aisles are filled with these plastic measures. Currently, we're one of the largest manufacturers in the United States of stock plastic measures, producing in excess of 150 million units on an annual basis. The number fluctuates each year depending on the customers and the economy. We monitor our inventory closely with a min-max stock level and adjust it at least quarterly based on our customers' forecasts and the history that we're seeing in trending. Normally, we try to target about 7 inventory turns, so we keep our inventory levels relatively reasonable, but we keep our customers supplied with the product they need. That pretty much wraps up our tour. Let's take one last look at this ice bin. Again, what we saw on tour was the injection molded drain assembly, which you see on the bottom, the sheath that you see on the sides that created the interior of this bin, and the profile extrusion that you see here that creates the corner joint of this ice bin. I'd like to thank you for taking the time to come on the tour with us today. And if you need more information, please visit our website. Thank you.
PCN tours the Keystone State, taking you inside Pennsylvania's factories, museums, and historical sites.
Hello, my name is Aaron Heindel, manager of the Brown Cow Country Market. We're here today and we're going to show you a tour of our Hope Acres farm and how we go from calf to ice cream, the product we all enjoy. The whole process starts right here. It's in these pens behind me that the calves are born. And we have a calf that's born just about every day. And it's about 9-month gestation. All of our cows are artificially inseminated. And they're protected here in their own pen. The calves stay with their mother for a day. And then they are taken and given a formula, a mix that we make up that's high in the nutrients that they need. Once our calves are about a week old, we take them down the road to another farm where they raise them until they're 6 months old. And then we take them to another farm where they're raised until they're about 3 months before they give birth. And then we bring them back here to these pens, and that's where the whole process begins all over again. Well, this is our farm. As you can see, it's a rather clean barn. One of the things that we are very concerned about as we bring the public into the farm and to see things is we want to educate people that farming is not about just making milk. It's a lot more involved. You need to make sure your cows are happy. And so we built this facility to accommodate that and to make sure that the cows are treated very well and that they're happy cows. If you don't have a happy cow, the cows are not going to give the milk that we want. So some of the things that we've added to this barn that are little extras is simply the fact that there's water beds. Each of the cow, if they wanted to, has a place for them to lay down. And when they go in and lay down in that water bed, it has a little bit of a barrier so that they're not laying right on the cement. And this protects their legs, their knees, from constantly getting up and down. It can wear out their legs. And once a cow's legs are bad, doesn't matter how good the cow is and how good the production is, the cow really has no more worth. So it's important to protect their legs. One of the other things we've done is we've put rubber on all the floor that they walk on so that they're not walking on the cement. This aids in protecting their hooves as well as, again, their knees. It'd be very similar to what we are familiar with anti-fatigue mats. It just adds that little bit of an extra cushion to take the stress off of our joints. The other thing that we have done is we've installed this automatic manure scraper that keeps the manure constantly cleaned out. And as you look at the cows, you can see they're very clean, because most of the cows, when they lay down, they'll climb into bed and they don't have to worry about going through a bunch of mud. One of the other things that we have added is the red brush that you can see in the back, and that is simply what we call a back scratch and has been termed a spa. The cows are able to go in there, and again, it has really nothing to do with milk production except for the fact that they are unable to scratch their backs like we can, and so we put something in there to help whenever they get that itch that just is driving them crazy. This area right in front of us here is the holding area. When the cows come into here, they can only get food by going through the milker. And this allows us to be able to gather cows in who may not have milked within the last 8 hours. For some reason, they may have got overeating and never got around here. So one of the hired hands will come in here and round up those cows who need to be milked because they've overextended their time between milkings, and therefore the cow has to go through there to get back out into the feed area. Now we're going to walk through the robot room, and we'll just take a look at some other the accommodations that we've added for the barn. Again, just to increase the cow's comfort. One of the other things that we've been able to do with this barn is we've made it so that they're free to roam. In our other barn, which we used to have, all the cows were tied in their stall, so they were pretty much stuck there. But with this facility, they're able to roam within their quarter. The barn is divided into 4, and each quarter of the barn has its own robot. So there's 4 robots, and these cows have access to that 24 hours a day. So they're free to roam around. They're able to eat 24 hours a day. We have food in front of them constantly. Cows eat around 50 to 60 pounds of feed a day. And then we also have fresh water that's available to them 24 hours a day. Cows will drink anywhere from 30 to 40 gallons of water as well. So it's very important for their milk production to be able to have constant access to those 2 things. The other thing that we have is a temperature-controlled environment. It's not quite as specific as the ones that you have in your home, but for the cows, it works very well. The walls, there's walls that surround 3 sides of the barn. The one end is completely open to allow fresh air in. And today, the walls are down on the side, and that is because it's a very perfect day for cows. It's in the mid-60s. But as the temperature increases and it gets hotter, the side walls will go up automatically, and all the fans on the end here will come on, and what it will do is it'll make like a tunnel through the barn. These big white curtains that are hanging overhead are actually wind baffles to direct the wind down on top of the cows, again, to reduce the temperature. Cows' body temperature is about 140 degrees, so again, when it gets in the winter here, their body temperature keeps the barn pretty moderate. And the walls on the side go up, and everything is sealed off except for the one end. And the barn is built so that it, for the most part, the winter winds are protected and not coming into the barn. As you look around, you'll see that the barn, again, as I said, is divided into 4 parts. On the one half, we have all our Jersey cows. The reason for that is because we use our Jersey cows for up at the store. Since they are brown, that's why we called our store the Brown Cow Country Market. We use their milk primarily because it's higher in protein and it's higher in butter fat. Most people are familiar with the Holsteins, which we have on the other side of the barn, and the Brown Swiss. The Holsteins produce a lot more milk, but their butter fat and protein is not as high. We use the Jersey milk, again, because of the butter fat and protein. And as a result, we're able to get a better yield. Because of our concern with one of the current issues with hormones being used, we have chosen to not use hormones in our cows that we use at the store. So our Jersey herd is hormone-free in that we do not add any hormones to them. BST is a natural occurring hormone in cows. However, in order to increase the herd average of milk production, many farmers have gone to giving shots to increase the length of production, length of days in production, as well as the amount of production. And this is simply because farmers are being made all the time to become more and more efficient. If we were to go back to the 1930s and look at the price of a gallon of milk and also compare it to the price of a car and the price of a home at that time, and then bring everything to the same markup or same inflation as today, we would be paying anywhere from $10 to $12 a gallon of milk. But farmers have become more and more efficient, and that's one of the reasons why the robots are such a huge success for the farming and dairy industry. We have opted out of using BST in our Jersey cows simply because we realize that anything that you're adding to nature probably is not the best thing for us. And so we have chosen not to give our Jersey cows any shots so that we can use our milk in our store and it'd be as close to natural as possible. One of the things that people always ask us is, how do you get a cow to go into the robot? It's very much the same as trying to teach a toddler to be potty trained. It's just simply a process of taking it from one habit to another. We used to go to the cow twice a day and milk the cow. Now we've trained them to not wait for us. And so when they get that discomfort of their bladders filling up, they simply make their way to the robot. And we use what we call cow cookies as a way to entice them. It's a mix of roasted corn and roasted soybean that they only get when they go into the milk room. And if the cow tries to sneak an extra bite and they try to go in there right after they've been milked, the robot recognizes that and will not drop down the cow cookie or milk them within 6 hours of their last milking. The cows can go in as many times as up to 5 times a day to be milked. And what this allows is for them to have less discomfort because they no longer have to wait for us to get there. And many times in the past, by the time we got to them for milking, they were already beginning to leak milk because they are past their capacity. They have passed the capacity for which they can contain. So now they're free to enter the robot at any time. All of our cows are artificially inseminated, and it's a process that we do the cows stay in milking for about 350, sometimes maybe it's 365 days, and then they go on what we call a 2-week sabbatical or vacation, and that's 2 months right before they give birth to their calf. And the calf goes to its mother for a day, is with its mother basically for a day, and then we pull the calf from the mother and we mix a formula. It's a mix that we give the calves, and then the cow comes out into the barn so that she can be milked. The calves then go off-site to another place and are raised until about 6 months or so before they give their first calf, and the whole process starts all over again. Here we are in the robot room. It's a small cement room within the barn. There's 2 of them. And then we have 2 robots in each room, so a total of 4 robots. Each robot can milk up to 70 cows. Our barn is built to hold about 280. At present, we have about 180 in the barn. As you can see here,